All right, continuing on. I copied this formula from page 2 of your yellow sheet. So you might want to get out your formula sheet to just take a look at that. It's important that you understand, you're going to hear referred to a test statistic. And remember, we're doing a normal model. So our test statistic we're going to use is Z. And to calculate that, you take your statistic, which is p hat, minus your parameter, which is p, divided by the standard deviation of the statistic, which is the square root of p times q over n. Oops, I don't know why. I was going to, hold on a second. All right, so we'll fix that, maybe. Over n. All right, so this is your test statistic, and again, I'm just following this formula. Later, we're going to do some other tests that won't be with a z, so that's why we need this formula. So some of these things will change when we're doing different problems. So for our particular example, our p hat value was 0.1747 minus p. Now, if you want to, in the formula, you could call this p naught, because these are always going to be our null hypotheses values when we calculate our test statistic. So it might help you to remember that if you put p naught, which was 0.24, divided by our standard deviation, which was 0.0134. So we can go ahead and calculate this. And I get a z-score of negative 4.87 if I go 2 decimal places. So this is almost 5 standard deviations, because remember what a z-score is. It tells you how many standard deviations. So it's almost 5 standard deviations below the mean. So let's actually calculate the probability that we would have a value that's that low. So if I go to my calculator, I just seem to have lost. All right, so if we take a look here, now I want to find, I'm doing a z-score this time, so I'm going to go second distribution, and I want normal CDF. So I don't have our little fancy display on this one, but I want to the left. I'd be shading to the left. I can't even shade it on my picture because it's so far down here, but I'd be shading to the left. So I want negative 10 to the 99 for my left bound. And for my right bound, I'm going to put negative 4.87 because I'm actually using the z-score. Now remember, when I use a z-score, the mean is 0 and the standard deviation is 1. Actually, I shouldn't have referred to this picture anyway. I would be looking for this 0.1747 if I was shading that, not the negative 4.87. So you actually, if you're using z-scores, you don't need to, it defaults to a standard normal. So if I push enter, look at this value. Now remember what this means. So the probability of having a z-score value that's less than negative 4.87 is equal to 5.6 times 10 to the negative 7. That's pretty much 0. Now, one thing that you do have to do, because if you remember from the very beginning of my test, I was doing a two-sided test. And when you do a two-sided test, we don't really know that it was going to be on the left side. We have to take into account that we could have ended up on the right side instead. So when you do a two-sided test, you have to double your probability of getting the value that we got. If I was doing a one-sided test, I wouldn't have to do this. So I'm going to multiply this by 2. So I get 1.1 times 10 to the negative 6. I'm still pretty much 0. Now this right here has a special name when you calculate this. And this is called a p-value. And you're going to hear a lot of talk about p-values when we do tests of significance, a significance test, which is what this is called. So our p-value, how we're going to interpret this, and that's really important that you know how to interpret it. And so this is, I'm going to, just like I gave you a little fill in the blank, almost kind of interpretation for confidence interval, I'm going to do the same thing for a p-value. If the true proportion of blue M&Ms manufactured is really 0.24, then the probability of getting sample results as extreme or more, because remember we were shading to the left, as extreme or more than ours, is 1.1 times 10 to the negative 6. This is extremely unlikely. Okay, remember what the claim was. Because our p-value is so low, it is so unlikely that if the true proportion is really 24%, it's so unlikely for us to get sample results like we did that we could then say that the proportion that the company claims must not be true. So this is extremely unlikely. So we have evidence, actually we have strong evidence, to reject the claim. I'm just going to say to reject the claim of 0.24. Now, when we reject the claim, now we can say that the alternative must be true and state that the true proportion is different. Now, the reason why I didn't say is less than is look back at what your alternative was. We said we tested that the proportion was equal to 0.24, and our alternative was it was different than 0.24. So if I reject my null hypotheses, then I'm going to accept the alternative, and the alternative was just that it was different. So this is what you would do, including the interpretation from start to finish of a hypothesis test for proportions. One last thing I want to show you. On your calculator, you can, just like we could do a confidence interval, you can do a significance test. So if you hit Stat and go over to Tests, and we are doing a 1 proportion z-test, so we'll choose that. Our p-naught value was 0.24, so that's what we were showing to be true. For x value, we need to put in the number of blue M&Ms, and we had 178. For n, we have to put in our number of M&Ms in our sample, so 1019. And then we have to state what kind of test we're doing. Well, we did a not equal to test. Sometimes you could do a less than test or a greater than test. These are one-sided tests, and when you do a one-sided test, it doesn't double the probability. Now, when you do calculate this answer, if you take a look at this, and it's going to be a little bit off because of because I rounded when I did the z-score. So notice it gives me my z-score. See this p-value, right? This is the p-value, 1.05 times 10 to the negative 6. That corresponds to what we got. other than rounding. It gives me my p-hat value that was my sample proportion, and it tells me my value of n. Now, it's fine to do a test on your calculator. It does not take the place of setting up your null hypotheses, your alternative hypotheses, your explanations, checking for all your conditions, drawing a picture, your interpretation and your conclusion. All of those things have to be very well written. This is the easy part, making your calculations. And so that can be done on a calculator. However, you should still know how to calculate a test statistic even without using the calculator. I'm not assigning problems to do from the book today with this assignment, but I am going to expect you to be knowledgeable of this material, and so when we are in class tomorrow, we'll be able to get right to work with some of these types of problems.